I think I lit light. 1 second. Okay. Hello, hello. Welcome to the stream. So, what we have today, I'm not gonna go to blah, 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 blah. I want to go back to working and working for good. So we have here Voxel Tools. And if I go to Godot Voxel Tools, I have an issue yesterday with no building because of Voxel Tools. And if we go here, you see the issue is no longer here, it's in the closed, which was closed yesterday. See if there's any other reply, blah, blah, blah. And we close this issue. So now the Voxel Tools builds, and I managed to build it. So we have the latest version of Godot. That was because this is important, because every time the Voxel Tools breaks, I cannot build Godot, because I have to build Godot with this, in order to have that beautiful procedural terrain generation. So we're gonna go also in documentation, which is here, and today I'm gonna read the documentation mostly. It's not gonna be an exciting stream, I'm afraid, because I want to go through the documentation, because it have been months since the last time I streamed. And I have to refresh my memory exactly how the Godot Voxel tool works, and then we can go back to actually making the terrain and see how far we can go with this. So today is a reading day. Nothing too excited. We're just reading and trying to find out how the Voxel tool really works. So put some music for those that come to the stream and watch the stream. Actually, talking about stream, let's take a look at YouTube. Do you have updated on YouTube my stream? I think I'm gonna make this one available. No, I have to go to Studio, YouTube Studio. And I think here, there must be my stream. I don't know if it's really, however, ready. Because YouTube takes forever to sometimes upload the stream. Okay, so there's the content, right? It have been some times the last time I actually uploaded the stream. I'm not gonna include the previous ones because I don't give a shit. Has been some time. Let's delete those. How do I delete those? More actions. Delete forever. Yes, delete those. And keep only the last one. All the other ones are uploaded. Yeah, I'm gonna upload this one. Let's see this one. Does it stream? Can I see it? Is it everything okay with it? So that was the yesterday stream. 16th of September. Okay. Yeah, the quality is fine. It sounds interesting. Yeah. I haven't done anything special about the stream, but it's okay. Let's upload the stream. So we have to put it on Ephestos live log. I think I also want to add, do I need tags? I don't think so. It has already gamed codecs and tweets. Okay, so that's fine. I don't give a shit about the rest. And what else we have here? Public. Let's make it public. I don't want to premiere it and not schedule it. I think it's ready to go. And let's put that first page. It's not age restricted. It's not made for kids. It doesn't contain paid promotions. Automatic chapters. Yeah, I don't care about the rest. So let's upload this. It's already high definition. Let's go back. Okay, now it's... What the hell? Why still private? You're kidding me, right? I say public. Done. Save. Okay, it's public now. Let's go back to my channel. Your channel. This is my channel for those that don't really know. And now here I should have this one, which is my latest stream. One view, October 5th. Okay, upload, run. Run like the wind. And I think the previous one was, the last one I uploaded was when? Was 3 months ago. Psst, it has been 3 months, wow. Request. And maybe, who knows, bring some okay features. So that works nice. So that works well. That's all. Okay, let's go now to do the documentation. So right now I'm using the generator graph for doing what I'm going to do, which is this. Which is this one. So this is the generator graph. But it also has the option of using a script for generating the terrain procedurally. But that script, from what I've seen here, it's only for C# or GT native. But GT native is basically C++. So it doesn't have an option for GT script to create. Let's take a look at this generator script. Is it only C# and C++? From the looks of it, this one is... It doesn't say, but it definitely is not GT script. Actually, this one must be C++. So for high performance, we need something like C++ to generate complex terrain. So I'm gonna stick with the graph for now. I don't want to mess with C++ and see how far it takes us in terms of performance. I probably will not make a very complex terrain anyway, so I think that the generator graph should be good enough. Let's open the generator graph as well. Okay. So generate. Wait, what? What's the generator graph? I have. So the generator graph can be controlled from C++, if I'm not mistaken. Cool. But can it be controlled by GT script? I don't think so. Doesn't seem so. That it can control by GT script. But that's not a problem. We can actually probably make some methods for GT script to control this, if that's supposed to be necessary. It kind of makes sense that you don't want to mess with GT script with procedure generation, because that has to run every single time, every single frame. It has to run the generation of the mesh. So every frame doing GT script is not a good idea. GT script is not really that fast. But there are some cases where it makes sense when the player changes something in the terrain. It may make sense there to run a GT script that doesn't do any calculation. It's basically maybe loads another terrain or something like that. Or maybe changes only one property from the terrain, which will not require a heavy recalculation. So it will not really matter if it is done in GT script side. But we will see about that. Maybe I will extend the API here to include GT script as well. I was always thinking that it was always available from GT script, but from what I've seen here, it's not. The scripting API is basically C++, or maybe C# as well. Although it doesn't mention anything about C# here. So I'm not quite certain how you control this other than C++. because my C Sharp knowledge is a bit rusty. I haven't used C Sharp for over 20 years. So I don't know. And frankly, if I have to choose between the two, C Sharp and C++, I will go C++ for more performance. Okay, let's continue with the tutorial and we'll see how it goes from there. What? Okay. So it uses one that's called Voxel Tools to store the voxel information. 3 channels. One is the type of the voxel. The other one is the SDF, which is basically the science distance field. This is actually the mathematical algorithm that generates the surface. And then it's a color. The first channels, while others are unused for now. And others. Okay, so it has multiple channels. How many channels it has? It doesn't say how many channels it uses. Each channel can also use. So we can actually embed our own information with the voxels. So like the type of the voxel, but also we can embed, for example, whether the voxel is animatable, if it animates, or whether the voxel is shared multiplayer. So we can embed other type of information and metadata as well through this means, although it doesn't really say exactly how it accesses the channels, but I assume it's inside the voxel tool class. And voxel buffer is used to save the data into memory or into hard drive, or also to the hard drive, to the disks. Okay, so there's also a voxel class as well. So this one is used only for blocky meshing, which we don't really care, only care about smooth surfaces. It's not general purpose voxel value and it will be renamed in the future to avoid confusion. So, okay, this one we don't use. Saving voxel disk, it uses the voxel stream. So what's the difference between voxel buffer is... So voxel buffer is only for the memory. The voxel buffer only saves the voxel to the memory, where the voxel stream saves the voxel to the hard drive. So we can save changes on the terrain. So we can use also compressed files for saving space. we have the voxel mesher, which takes the voxel data, which still is basically mathematical, and converts to an actual mesh, which is the most important operation, of course. So it can give us triangles that we can play around. And the nice thing is that we can access those triangles and we can manipulate with Godot, for example. So you can further manipulate the mesh via Godot. Yeah, that's just different measures. So we're using the transvoxel measure, which is the most advanced one. Yeah, and can stitch together two meshes of different level of detail, which is very important because we do level of detail based on distance from the camera. So we need always to stitch meshes that have different levels of detail because they're farther from the camera and they're closer to the camera. So that transvoxel algorithm is actually pretty useful. It's considered one of the most advanced, most efficient ways of doing voxels as a mesher, as a way to generate meshes. Dual marching cubes. Yeah, this is a simpler implementation from transvoxel. Voxel mesher on the other hand suffers from things that transvoxel solves, like stitching meshes of different resolutions, different levels of detail one another. So generally you want to use something like this for some of these maths, which is why he says here that this one is probably going to be removed at some point and is no longer maintained. So this one we don't really use. You use other Logi, which is for Minecraft kind of thing. This one, mesher cubes. I don't know what's the difference between this one and this one. The color of the voxel is used for this kind of views. I don't understand how these two are different. Okay, so this one can use custom meshes. So this is actually interesting to me because basically what I want to do is make spaceships. And usually when you play something like Empyrean, it has the ability to create voxel spaceships. So you assemble blocks together, but those blocks they are made out of static meshes that are different shapes. So they're not all blocks, they're not all cubes. You can have different shapes, so you can make spaceships that are very organic in looks. This one actually is pretty useful because it says here that you can change the custom meshes that are provided as a way to generate the mesher inside. So that actually may use. So an example of that is Empyrean, Galactic Survival, Spaceship, for example. To give you an example what I'm talking here. I don't want to fire the game, so I just want to show some images. So you can see here, this one. So, yeah, this one is actually made out of cubes that have custom shapes. So as you can see, it looks a bit cubey-like, but it has also custom shapes. It has corners. It almost has curvature. It's pretty much a very flexible way of doing it, and it uses a Minecraft kind of system, but Minecraft only uses cubes, where this one can use a lot of different custom shapes, like as you can see here, for example. And that is pretty nice. Okay, let's see the exterior again. I think if you do so, the exterior is going to be a bit more obvious. So as you can see here, it's not just cubes, it's custom shapes with corners and, and all this kind of nice stuff. So yeah, so that's exactly what I want to do as well. Look at this, how he actually made like a enterprise kind of nacelle kind of thing. So I assume that this one will require, as you can see, you can come up with some really very nice shapes. And it has, I think, like 100 different voxels in terms of shapes. No, this one is not. I don't think that's one. No, that's a concept design. It's not really shape. This one, for example, look at this, how, you can do pretty nice stuff with a voxel. So you can actually come up with some really very flexible designs. And exactly this is what I wanted to add to my game as well. So it seems that in that case, we're going to be using something like the measure blocky. So it says here, this can also use cubes, but any shape will do if custom meshes are provided. This is a similar technique as the one used in the Minecraft. It has a wide range of options. So that's exactly what I want, custom mesh. So that basically means that I can use transvoxel, the mesh transvoxel for the terrain, because usually you want something smoother there. And I can use measure blocky for the spaceships and the star bases, which is nice. I don't have to implement this myself because I was kind of afraid that I have to implement this myself. So that's cool, especially if it has also physics, which is another thing I want to have in spaceships. Okay. Oh. So wait a second. This one also exists as no. This is a messer, so it exists only. So actually, let me take a look at this. If I go here and add a new node, 3D, voxel instancer. The voxel instancer is actually the ones that actually. So where's the terrain? Terrain. Voxel node. So there's always also only terrain here. There's also a modifier. However, the modifier mesh I think is the one that you can use for sculpting your existing terrain. So it can only take low terrains or terrains. So we have to use the terrain as well there. Interesting. I think that probably should be changed as a name because it's not used only for terrain. It's used for a wide variety of other things. Okay. look under the debug menu. You can also turn the collision wire mesh for debugging. In the editor, look under the debug menu. Debug menu. So, planet load. Inspector. There's a debug menu. The debug menu. Maybe it means this debug menu. Visible collision shapes. Debug visible collision shapes. Where is it? I don't see anything. You have to see it from inside. Okay, let's take a look at this. Okay, you have to open it inside the game. Okay, so we see here the collision shapes. Yes, yes. Yeah. Yeah. Okay, that works. Perfect. Nice. Can probably show you the visible navigation, deploy with one vikings, multiple instances, run one instance. What is that? 2 instances, 3 instances, 4 instances. No idea what that is. Okay. Oh, yeah. Oh, yeah. 4,000 different voxel types. That's pretty nice. That's a lot of voxel types. 4,096 different voxel types. Wow, that's a lot. So wait a second, this is only for blocky terrains. Okay, but this is can come helpful because we've seen earlier on that voxel measure blocky. What was that? It was saying. What was it? Measure blocky is the one that actually does different types of blocks, which I want to use. So maybe use this one not for terrain, but more like for spaceships and for bases, and use the load terrain, the transvoxel terrain for the terrain. Yeah. So yeah, 4,000 different. Yeah, that's pretty much good enough. It should be more than good enough for my taste. And theoretically, it's up to 65,000 voxel types, which is crazy large. So you can use atlases for texturing, I assume. Reusing materials. Yeah, textures. Using texture atlas. Yeah, that's how you. So you could do something like Minecraft here. That also can be useful for making spaceships and this kind of stuff. The problem, however, is how this works when you're using a voxel that has a different shape from a cube. How you UV map that? That's a good question. Because it says here that this voxel measure, voxel blocky measure, can take different shapes than absolutely like straight cube. So the big question is how exactly you do that in terms of an atlas texture, because it cannot be squares in that case scenario. I mean, it wouldn't make sense to be just squares. So that's a problem. I don't know. I'm thinking of not doing textures at all in the game and use some kind of procedural shaders, but we'll see how that works out as well. So yeah, this one actually uses square cubes, right? Simple cubes, which is why it works for them. But what happens if you use custom meshes? Left and right. Cube tiles, left and right. What is that? Also using tiles on each of their face. Can have different tiles, you can decide which one to use by signing. Okay, so this is like a UV map? Possibly. Yeah. That probably is a UV map. Okay. Oh. So this one is a cube voxel. Okay. If you change the geometry type to custom mesh, you're allowed to assign a mesh resource. In this mode, cube tiles properties are not available. Okay, so cube tiles only work only when you use cubes. When you use custom meshes, it uses its own custom UVs and custom textures for each mesh. Okay, that makes sense now. So basically the custom mesh here comes with its own UVs and its own textures and probably its own materials. Where here, this one, the cube atlas is only when you use standard cubes for voxels. Okay, I see that. So we can use this system for making the spaceships and the star bases, since it allows us. Although this is a bit confusing here because, well, it isn't, because this one is an entire voxel and it makes like a staircase here, which is on kind of material and its own textures. Keep it low poly. The measure can deal with large models, but performance can decrease very quickly if the complex model appears a lot of times. Baseline, as a matter of fact, I assume how much, but that's not really a problem because usually we call them voxel brushes in essence. When you use custom meshes, they usually are pretty low poly, so it's not really a problem. The sides of the 1-1 unit cube will be only faces that can be cooled by the mesher. Okay, so the mesher does cool faces. It does cool faces. Oh, he didn't mention that. So basically faces that are shared between different blocks of voxels, they are removed, they are cooled. Cooled basically means that they're not drawn or they are merged together. So it's a big question here is how does it any kind of mesh optimization for when you have metable voxels? Because if, for example, you put this voxel here, this one is one voxel, even though it has this kind of staircase shape. If you put 1, 2, 3, 4, 5 in this row, like you keep booked in those shapes because you want to make the staircase wider, that means that those faces here have to be removed. Because if you keep those faces, you basically generate faces that are not used and they're never going to be viewed from the user because they're internal in essence. That is usually done using a greedy mesher, as they call it, which allows you to delete and merge faces together so you have a more optimized mesh. And that is very important because I've seen Empyrean does this, and you can take a spaceship that is made out of these voxels, the different shapes and different sizes, and you can make it reduce its polygon count 2 times. So something that takes 100,000 triangles, it can be reduced down to 150. 100,000 triangles, it can be reduced down to 50,000 triangles. And of course, that's more important because you can have huge spaceships, and to be able to reduce the geometry down to half, it's a great optimization. I don't really know. I think he's doing something similar here, but I don't really know exactly how he's doing this and how much the cooling is really optimized. And does it call it in terms of not drawing it, or does it call it in terms of merging the geometry? Does it actually affect the geometry? That also is a good question. If you hear me clear my throat all the time, I have the flu, like exactly more like 1 week ago, and I'm still not 100% okay. So I'm still trying to recover. Actually, I will take a break now for 10 minutes and come back as soon as I finish this one. And choose the models from me too, but we're going to do it in Godot because let's reuse them. Used in its model. This is second material is used in its model. This is useful given a mesh needs both transparent and opaque power. This works as usual, but having a mesh with 2 surfaces. However, phase cooling will still use properties of the model regardless. For example, if a model has opaque sides and is transparent in the middle, it may be defined as a non-transparent block. So when placed next to another opaque block, geometry of its size could be cooled. So yeah, the cooling. I would like to learn more about the cooling method. What exactly it does? Is there any mention to the cooling method anywhere? Probably it's mentioned here in performance. We still have all these things to go through, documentation-wise. So I'm going through the main documentation, which is this one, and then there's a scripting API, which is, of course, has all the classes here. And then it has a special mention for the kind of formats it has for storing on the hard drive. So I'm not going to go through the entire documentation. I don't think I need to. Probably will focus on a few things that I care about. But it will be a good idea to get a good idea. It will be a good idea to get a good idea what the engine is doing if I want to use it in the correct way. Okay, so what it says here is that each two faces touch each other. If they have the same transparency index, they can be they can get called. But if actually, let's take a look at this. Called. Is it how you pronounce it? Called.
Cold.
Called.
Cold.
Called.
Cold.
Okay. So that's the Oxford, which is the British one.
Cold.
Cold. Okay, so cold, the cold, and but if the transparency index is different, they may know. This also leaves. Okay, so transparency does play a role here, which makes sense. Okay. Random tick. Messer cubes. Accurate and feature written how it has Dropbox time. It's going to have to be built. It's time the terrain is modified, which is very slow. Very slow. So collision shapes have to build each time the terrain is modified. So the terrain is modified in this case only when I'm doing excavation of terrain or you want to build on terrain and add stuff to the terrain. So it's not really something you do all the time. So yeah. So there is an alternative collision class, which is the Voxel box mover. So is this applies only to, where am I? I'm in blocky terrains, although I would like, I wonder if I can apply that. Well, yeah, obviously the blocky terrain. You will lose precision there. Yeah, it only works if you use the Voxel meter blocky. Okay, that's not a problem. It means the collision detection for our spaceships and star bases will be a bit faster than the terrain itself, which is nice. Although you don't really get much collision anyway between spaceships, you just fire weapons, and that's about it. The only things you can do, maybe you do an explosion, or you want some things to fly off the spaceship, the way I see it. So physics-wise, you don't really care so much about the physics in a spaceship, other than having a realistic flight system where the weight of the spaceship affects you how fast it accelerates, and maybe the gravity of the planet also affects the spaceship itself. That's basically the things you may, worry about. So we're going to keep this in mind, the Voxel box mover. And then we have the raycast. Raycast is important when you fire lasers and fire weapons that have projectiles. We can go back to this already. So what's the next chapter? The next chapter is smooth terrains, which is what I'm using. Okay, so I'm going to take a break and come back and then see smooth terrains. And yeah, we have already viewed like half of the documentation from the looks of it. So I don't think I'm able to finish the documentation today, but I think next stream probably will finish the documentation and then go back to make it a terrain, because I want to have a good idea how the system works. Otherwise, I have no idea what I'm doing. So yeah, thank you guys. See you on 10 minutes. Okay. So we go to smooth terrains. See what we have here. Is it? Yeah, that's full charged. So that's what we use here is the Voxel Master Transvoxel, which is for smooth terrains. Oh. Fair enough. Give me a second because my screen is so dirty. Beyond dirty. Yeah. Wow. So dirty that it doesn't even clean. This one is also dirty. And this one is dirty. That's much better. Something bit. Okay. Okay. No idea what's doing here for stitching messes, but I have no idea what he's doing. So I will just go through this. I don't know idea what he's doing exactly. It's beyond me. But whatever, yeah, I don't give a shit. If it works well, it works well. Κάνω κόμμαχη. So it uses normal maps here as well. It can generate its own normal maps for added details. So here he adds more detail using normal maps that are generated on the fly, but it makes the generation a bit slower, which is cool. A lot of features, I like it. So I'm going to end the stream with this final chapter, and I will come back tomorrow, continue reading the documentation, and hopefully maybe Friday or Monday or Saturday, we'll see, we go back to modifying the terrain. But yeah, I want to go through the documentation first to make sure that I understand completely what's going on. So I'm going to read this one, which is generators, and then end the stream here. It says here that in the future we're going to have more math nodes, graph nodes, more graph nodes for high level stuff. Yeah, here it shows how to make a cave system, which is also something I want to implement, but not for now. I'll leave it for later. I want to first of all understand how to make the terrain look a bit more realistic and a bit more interesting. Okay. I think that's enough for today. We are in generator, so next time we will go for streams, instancing, editor, multiplayer, scripting, performance, and module development. So yeah, should we rate something? Let's see. Is anyone online right now? Let's take a look. Tweets. Twitch TV. Ah, Rise is online. Okay, so let's rate Rise. There's also Harwacha. Harwacha. He doesn't have a lot of viewers.
I mean, in the classical case.
Yep. Let's rate Harwacha. Okay, thank guys for watching me. No, it wasn't really exciting today, and it's not gonna be exciting tomorrow. Because it's reading time, documentation time. So I have to go through the documentation, and as soon as I finish the documentation, we can get some action. But for now, we are in the learning phase for the next few months, and see how that goes. So thank you everybody for watching me. See you guys next time. Bye bye.
And this would be like the roaming area where the player can freely go around. Is this like a different level? You don't see perspective changes often within the game. No, this is not another level. What I'm planning to implement with this isometric style is kind of like a level select